What is MBCEA? The Metal Building Contractors and Erectors Association has a long history of helping its members achieve new heights. As a membership-driven association, the MBCEA proudly includes individuals from all segments of the metal building industry. So join us and see what you can get out of membership. We have industry-leading training programs such as our MBI quality and craftsmanship training and the only world-recognized accreditation program for metal building sellers. The MBCEA hosts an annual conference here too, or visit outstanding topics and seminars created by contractors and erectors or contractors. Trainings, events, and seminars, even a mentor program, all based around the wisdom of our experienced members. But our best asset is you, sharing your knowledge and experience with others that moves our industry more forward. Achieve heights together. So join today by going to our website or call us now.
Hello, and welcome to this 8th session of MBCEA's 51st Annual Conference Gone Virtual. We've had almost 300 download the Whova app, and more are registering daily, so we're really excited about that. If you're attending for the first time, I'm Sasha Demian, Executive Director of the MBCEA. Thank you for joining us. The 2 promo videos that we play at the beginning of each of our webinars are located on our YouTube channel. Please subscribe and use them in speaking with potential members. If you're not a member, I hope they encourage you to check us out and join. Before we begin today's session, I just want to make sure that you know that whether you're watching through the Whova app on your cell phone or on your desktop, there is a Q&A section. So please feel free to ask a question or respond to any that are raised, and we will make sure we get to them by the end of the presentation. Today's live webinar is Airtight, Get It Right by Vince Sagan. Vince is a senior staff engineer for the Metal Buildings Manufacturers Association. He manages multiple research and code development projects for the MBMA, including the Air Infiltration Project. I'll turn this over to Vince now.
Thank you, Sasha, and welcome to the presentation, Airtight, Get It Right. My name is Vince Sagan. I'm Senior Staff Engineer at the Metal Building Manufacturers Association. So let's get started. So what we're going to be talking about today is air leakage requirements and energy codes, and this is going to be just a brief overview. I hope everyone attended Bill's presentation a week ago where he got into a lot of the details on the energy code. I'm just going to be focusing a bit on the air leakage requirements in the energy code, just enough so you know why we're doing the testing and where it's required. And then we're going to go over the air leakage testing procedures so that if you're interested, when you're exposed to this in the future, you have a pretty good idea what to expect. And then we've actually have performed tests on four buildings in the past year, and we'd like to present the results for those buildings. And then the end goal of this project is to develop a best practice guide. So there'll be a slight discussion on that, so you understand what's going to be included in that best practice guide. And then we're going to talk about future testing. So let's get started. So let's start with the air leakage requirements in the Energy Code. So there's these national energy codes that are adopted by the various states. And if you're involved with any of the energy requirements, there's ASHRAE 90.1, and then there's the International Energy Conservation Code, which is developed by the International Code Council, and that organization also develops the International Building Code, or the IBC. So let's look at some of the requirements here. So the testing needs to be done according to an ASTM standard that is specifically for this testing. And the testing involves not just, it involves doing a test with pressurization and depressurization, and then the results are taken and averaged, and that's the result. I think everyone could appreciate that when you basically fill up a balloon, you pressurize something, it's going to behave differently from when you actually basically pull air from the outside in. So that's what that's trying to capture. And currently, the air leakage requirement in most of the codes is 40 hundredths cubic feet per minute per square foot. So it's a flow rate over a surface area, per surface area. Now, there are lower limits that according to the United States Army Corps of Engineers. So if you've done government work, you're aware of that. And also Washington State has its own code, and it has its own lower requirements. Right now, they have 25 hundredths cubic feet per minute per square foot. Currently, the current IECC and ASHRAE 90.1, the whole building air leakage testing is an optional compliance path, except for in a couple of locations in Washington State. However, that's changing. In the near future, whole building air leakage testing is going to be mandatory. So in the 2021 IECC, which that was just completed, it's going to be required, but there are some exceptions. Remember, this is the building code. So, and once you start seeing these exceptions, you're going to say, oh, so this is how codes are developed. So there are some exceptions in various zones, and I'll be showing a map of the zones. These zones are typically where it's hot and dry, so it's not a humid environment. And then there's some other exceptions if it's greater than 5,000 square feet in some other zones. And there's another exception. So welcome to the beauty of code development. Now, if we go into 2019 ASHRAE 90.1, and I see a typo there, forgot an S in the ASHRAE, there are some exceptions. Semi-heated, zones 1 through 6, and also there's an installation verification program option. So let's take a look at the map of the zones. And you look, this is the map of the United States, and basically the different colors represent different zones. And I think they did a pretty good job as far as selecting the colors, because the warmer areas are the reds, and then when you go further north, it's cooler, and so the lower numbers are in the south, and they proceed up to higher numbers. And then the A, B, and C, A is moist, and that's pretty much from the Rockies to the east. Then there's the dry zone, which is B, and the marine is C. So if we go back to some of these exceptions, you know, again, B is, if we look at B, though it's dry, and 2 and 3 are more towards the south. Zone 1 is definitely in the south. So that's kind of a way to to figure out where you're located and where some of these exceptions apply. So let's look at some of the testing procedures. So when we do a test, what we'd like to figure out is, our focus is the building envelope and how well the installation of the insulation system is and how well that performs. I think everyone can appreciate that the overhead doors can be a significant area of the exterior of a building. And depending on the door, that can contribute or not contribute to the air leakage. So one thing that we do in our testing is we actually do a test with the doors sealed and the doors unsealed, so we get a sense of the contribution of the overhead doors to the overall performance of the building. Because the selection of the door may not be under your control. That is something specified by the owner or the architect or another design professional. So another thing that's done is, and the photo on the right is a gymnasium building that we recently tested. And you can see all the pipes coming up out of the floor slab. All those need to be sealed off, because what we want to test is the building envelope and not necessarily air passing through openings through the floor slab for drainage. And that's included in ASTM E779. So the testing is relatively straightforward. You basically get some very high-powered fans and you put them in a man door, and the number of fans that you need is really dependent on the size of the building and the air leakage of the building. And what we try to do right now with our testing program is limit the size of the building so that we can fit all the testing firm can fit all their fans in one vehicle. And then these fans are operated using a computer program. The testing firm brings a laptop, hooks it up, and then they can both do pressurization and depressurization using these fans. So the setup is pretty simple. The building envelope needs to be complete, and the fans are set up, and then the testing begins. Now in addition to that, you can get the values of the leakage from pressurization and for depressurization, and that's the basic test. Also, what's helpful is to figure out, well, where is it leaking? If we don't meet the test, the code says you have to address that leakage, and either between certain limits, and I'm not going to go into great detail on the code requirements, but you need to figure out where it's leaking. And filling the room up with some artificial smoke, and if anyone's an ex-rock and roller from the 70s and you have your smoke machine, this is a good application for whole building air leakage testing. And so when the building is pressurized, then when the testing is done, they pressurize the building, fill it up with smoke, and we figure out where things are leaking on the outside. Another tool that's used is a thermography camera. And basically you can use the thermography camera to determine differences in surface temperature. And from that you can find thermal shorts in the building envelope, and you can also determine possible areas for air leakage, because areas where there's cool air outside coming into the interior, that's going to show up as a cool spot or a thermal short. So those are some diagnostic tools that are used, and the testing firm that we've been working with brings the artificial smoke. They also have a smaller tool. It's a smoke wand, and it's about the size of one of those butane lighters, that you use to light your grill, and the smoke can come out and it can determine whether small areas where there's air leakage. So as I said, we've tested 4 buildings over the past year, and I'd like to share some of those results. So the first building we did was back in January. It was a cold morning in Mooresville, North Carolina, and we were working with with J.W. Wilson, and Wade Wilson was very helpful in performing this test, especially this was our first test. So some details on the building. The plan area is about 12,000 square feet, and the air barrier surface, that is measured by the area of the walls, the roof, and the floor slab. And you would think, well, the floor slab? Well, yes, the floor slab. And it's a warehouse building, so it's a more traditional sort of building envelope. You got standing seam roof, metal panels, a single layered face fiberglass insulation over the purlins, and the wall system was similar as well, through fastened metal panels. So here's some pictures of the building, and you can see that warehouse building had a significant number of overhead doors. A good part of the day was spent just sealing up those doors. It was a beautiful sunny day, but it was cold. Some pictures from the inside. So the picture is showing, we've pressurized, after we did the testing, we pressurized the building, they turned on the smoke machine, and what we were finding that the predominant leakage area was the joint below the floor, the joint between the base of the wall and the concrete slab. And then another location was the saw cuts around the columns along the perimeter. Those actually extended through the slab out to the edge of the concrete slab. So the smoke was literally pouring out of those joints. And on the right is a photo of thermography, and you can see some indications here. This dark band is the rigid frame. These lines here are the purlins, and then above are the roof panels and the insulation. You can see that there's actually some areas where there's some thermal shorts. And again, on this particular day, it didn't get any warmer than 40 degrees. So there is a dramatic temperature difference between the outside and the inside. So that shows up pretty clearly with the thermography camera. So let's look at some of the numbers. So again, on the bottom, that was the limit, 40 hundredths cubic feet per minute per square foot. So with the doors unsealed, we got 0.21, so it passed the test. And the pressurization, we had some issues with the equipment. With the doors sealed, again, with the doors sealed, it was 13 hundredths. So you can see that there is, even though it passed with both sealed and unsealed, you can see that there is a change in the performance. If you do the math real quick, it's at least not quite 100%, a 50% difference, but a significant difference. So let's look at the second building and the results. So again, this was a building that was erected by J.W. Wilson, an MBCEA member, and very active in the Carolinas chapter of MBCEA. And this was about a month and a half later, and it's the same site, same clients, but they had an office building. And this was a little bit of different sort of structure. You can see that the plan area was larger, with a larger and a corresponding larger air barrier surface. The roof was a standing seam, metal panels, but there was more insulation. You could see it was an R30. It was a banded liner system with 2 unfaced layers of fiberglass insulation. And the walls, there was actually 2 wall systems. It was different in the front, and the front was different from the back. And here are some of the details. So in the front, the owner wanted a different look. He wanted a brick veneer look. So the front half was a very non-traditional metal building facade. You had steel studs with fiberglass bats, gypsum board, a vapor permeable building wrap with a brick veneer. And then in the back was metal panels with a single bat, R19, fiberglass laminated. and it was a through fastened metal panels. Now, when it comes to the air leakage testing, this would be a great example or great application to doing the whole building air leakage testing, because you've got these two different systems in the same building. So here are some other pictures from the building. The one on the left is more of the storefront, and on the one on the right is the back, and you can see that there's a good size overhead door. So there are two overhead doors in this building. Now, when we did the smoke test, the picture on the left-hand side, you can see that there's some smoke, and it's pretty much coming out of the perimeter of the windows, which I think everyone can appreciate when they're trying to put together a building. When you have different materials coming together, that interface is always a challenge to get that right for water and for air leakage. And the picture on the right is thermography, and what that is a picture of is up here at the top is the window. This is the window sill, and on the right is the jamb. What's interesting about this photograph is it seems to me that they got the jamb on the left-hand side well sealed for air leakage, but not necessarily on the right. So let's look at some of the numbers. Again, a reminder that the allowable leakage is 40 hundredths. Let's see what we got. So with all the doors unsealed, 40 hundredths. So it passed the test. With all the doors sealed, again, you can see the performance difference. And again, these buildings didn't have to pass this air leakage test. It's not required in the North Carolina Building Code currently. But if it had to, it would pass. Both these buildings would pass. So let's look at the next building. And again, the contractor for this building was J.W. Wilson, and it's the Cannon School Athletic Exercise Building in Concord, North Carolina. So this was in April. The weather was warmer, which was appreciated. So some details as far as dimensions and the construction of the building. Again, it's a smaller building. It's 5,000 square feet. The air barrier surface is significantly smaller than the other two buildings we looked at. It's only 16,000 square feet. The insulation system, though, is different. For the roof, we have a through fastened metal panels, and we have a double layer unfaced fiberglass insulation, and then a field applied vapor retarder. And then the walls, through fastened metal panels, unfaced fiberglass insulation, and then a field applied vapor retarder. So we're looking at a different system here. So here's some pictures from the outside, and it's a very symmetrical building. Some engineer must have designed it because it's a perfect rectangle and it's symmetrical. But look from you go to one side, it's a mirror image of the other. The other thing I would like to point out to this building, the white panels up here, these are translucent panels to provide daylight in this facility. And I think everyone can appreciate that the translucent panel is not going to have the same insulation value as the insulation in the regular walls. We'll take a look at some thermography photos to see if that's really the case. So here's some pictures from the interior, and the picture on the left-hand side under construction. You can see that the insulation system in the roof is installed, and you can see that the wall system, the insulation has not been, the liner has not been applied, but you can see the unfaced insulation layer in the walls. And then on the right-hand side, it's more finished situation, and also a picture of the overhead door. There is exactly the same size door on the opposite side of the building. Again, very symmetrical, and then you can see the translucent panels up above the overhead door at the top of this wall. So here's some thermography photographs. The one on the left, you can see that the translucent panels are basically allow a lot more heat through. You can see that in the overhead door, there's some bright spots here along the jamb, as well as at joints between the panels of the sectional overhead door as well. And the picture on the right, you can see that, again, the translucent panels. And then you can see in the roof that there's some hotter spots here that go along the purlins. I'm pointing right now into the rigid frames. That's look pretty cool. But again, the thermography camera can be a useful tool in diagnosing thermal shorts and air leakage areas. So everyone wants to know the numbers. So how did this building perform? Now, the other thing I'm going to point out on this building, so this is the third building we worked with J.W. Wilson. And by the time we did the testing on this building, Wade Wilson knew what to look for. And he was looking at some particular details that he knew that could have been contributed to air leakage in the first two buildings that he did. And so I think that bears out in the test results. So with the doors unsealed, so the doors are unsealed, it's 0.52 cubic feet per minute. And if we were trying to meet the allowable leakage requirements, this would fail. And so if it was required to pass this test, you would have to do a remediation to address the leakage. But what are the numbers with the doors sealed? 0.15. So it meets the criteria, the limit, very easily. It even would meet the Army Corps of Engineer requirements of 0.25. So I think what this points out is that if you don't pass the test and you have to do a remediation, what do? What's the most strategic thing to do? And in this particular building, it might have been putting perimeter seals around the overhead door. So the last building that we have test results on is in Groveland, Florida. It was the Hope International Gym building. The contractor was Steelworks Solutions, and it was tested in December. And being in Florida in December was a nice place to be in the middle of December. Since I currently live in Cleveland, Ohio, and we all know that in the middle of December it can be cold. So let's look at some of the dimensions of this building. So it's a bigger building. The plan area is 16,000 square feet, and the air barrier surface is close to over 45,000 square feet. We've got a different insulation system. We have a standing seam roof metal panels, and we've got a faced and unfaced insulation system, R11 plus R19. The walls are through fastened metal panels, faced R19 fiberglass insulation. Let's look at some pictures of the building. It's a big building. It's a gymnasium. Not too many windows. The windows weren't installed. There was a storefront, but that wasn't installed, but it was sealed up for the testing. So we did the testing, and then we pressurized the building, and then we turned on the smoke machine. And then we went outside and took a look. And the major leakage areas were, again, at the joint between the base of the wall and the floor slab. That was a major area. Penetrations of the canopy, which I'll point out here. There was air leakage here with the canopy. And then another place that air leakage was prominent was between the two metal components around the storefront. So we've got some trim here that is part of the frame that's going to go where the storefront's going. And then it was just a contact joint between that and the metal panel finish closure detail, edge detail strip here. So then we use the thermography camera, and again, we're looking up and we're looking at the joint between the roof and the wall. And I think everyone can put together a building, and it's not just insulation, but when you have a transition between the roof and the wall, that can be a challenging spot to make sure it gets done right. And the picture on the left is that joint. The picture on the right, what that highlights is that there was some slight irregularities in the bat. So there was just a few extra wrinkles. And so relatively that was a hotter spot than the surrounding insulation system. So again, it's a nice thermography camera, helps identify areas that if you didn't pass the test and needed to go back to do some corrections, it can help you focus on what to look at. So let's look at the numbers. Again, the allowable leakage limit, if we're following IECC and ASHRAE 90.1, is 40 hundredths cubic feet per minute for square foot. Remember, it's an airflow over a surface area. Now, this building didn't have any overhead doors, so we just have one number. How about that? 0.09. And that's the best test that we found, and it meets all the current criteria. And I think one of the lessons from this test is that metal buildings with the current insulation systems can meet the allowable leakage limits in the code. It is possible. So this table is just a summary of the results, the various buildings with the walled and roof system, and it basically compares the average pressurization tests, with the doors unsealed and the doors sealed. And again, the lesson is that even 3 of the 4 buildings would have passed the current limits in the IECC ASHRAE 90.1. So again, the end product for this project is not just to go out and do some testing and travel around the country and do air leakage testing. What we want to end up is having a best practice guide. So the objective of this best practice guide is it's going to be a resource primary for contractors, but also for design professionals. Because again, the objective is helping the contractors meet the air leakage testing requirements, but we also want the design professionals to know that selecting the right door, overhead door, can go a long way to help meet the air leakage requirements. So that's the objective. So where does it stand right now? Well, we're currently under development. We've taken advantage of the travel restrictions and the self-isolation of the pandemic, and so the MBMA air leakage task group has started developing the best practice guide. And it's going to be based on testing performed so far. And that's only based on 4 tests. And we'll come back to that about getting more information. I mean, we're going to continue to add information with additional testing, and we want to do that. And people contributing to the best practice guides are members of MBMA, members of NAIMA, the testing firm we're working with, and we've also invited the Overhead Door Trade Association to help us with this, because it's in their benefit to have good information on overhead doors. And hopefully the information that we work together with will just make it easier for metal buildings when tested will pass the air leakage test. So what do we So what is this going to look like? So again, this is very preliminary. We're going to have a little bit on air leakage test code requirements. We're going to have a testing overview so that if you haven't had the opportunity, for people who haven't seen this presentation, they'll have an idea what's involved with the testing. And then we'll have recommendations for a successful test. And we're still figuring out exactly what we're going to do, but one of the task group members has suggested this approach. List various things that are most effective, moderately effective, and then least effective. And again, if we go back to that third building at Cannon School, if it didn't pass the test, in that situation, the most affected would probably be doing something with the overhead doors, because the contractor pretty much addressed many of the other conditions, and that for that building, that would have been the most effective. So as I mentioned, we want to do more testing. So we actually have some tests scheduled, tentatively scheduled. So C. Tucker Copeland Associates has volunteered 2 buildings for us to test. And they're in Columbiana, Ohio. And the map on the right kind of shows it's kind of midway between Cleveland and Pittsburgh. And I'm looking forward to attending that. It'd be a lot less travel. And so that's where the next test is going to be. And the bonus is that we're going to have 2 buildings to test. So there's an existing building that was constructed in 2016, and that was built according to the 2011 Ohio Building Code, and that corresponds to the 2009 IECC. So it's a little bit older energy conservation code. The building that's under construction, that's being built according to the 2017 Ohio Building Code, and that's the 2012 IECC. And for everyone who's been up, that follows the building code development, the energy codes are making, from one addition to the other, are making significant changes. So there's going to be a difference in the design requirements for these 2 buildings. So let's look at some of the details. So the first building that's currently exists, it's a relatively small area. Now it has, it's used for, it's the contractors building. And so there's 3 overhead doors. So we'll be able to evaluate the performance of these overhead doors. It's a standing seam roof, a fairly basic insulation system, an R19 fiberglass insulation. The walls are through fastened, and again, an R13 fiberglass insulation. The second building that's under construction is significantly larger. And the picture on the right, the highlighted area is the building constructed in 2016, and then here's the addition, or the second building. And this has 7 overhead doors. So seeing the performance of the overhead, as you have 7 doors, know that that's going to contribute significantly to the performance of the building for air leakage. Very similar construction, but you can see that the insulation system here in the roof is more robust. It's an R25 8-inch fiberglass insulation, whereas previously it was an R19. So you can see the impact of a more recent building code. So that's, we're waiting for, we probably would have tested that already if it wasn't for some of the travel restrictions due to the pandemic. So we're waiting for construction to be completed and the building envelope to be completed for that testing to occur. And we're looking forward to report those results and add them to the testing that we've done already. As I mentioned, we want to perform additional whole building air leakage tests. We want to get more information. A best practice guide based on 4 tests. I'd like to get some more. Now, it can be new construction or existing buildings, just like at C. Tucker Cope and Associates. And we're providing the testing at no charge. So the building criteria that we're looking for, the criteria for the building, the plan area between 8 and 15,000 square feet, and we've got some flexibility there. The limitation really has to do with how many fans can you put in a vehicle and travel to the testing site. When it gets too big, you need many more fans. Now, again, with the criteria, we have flexibility. Want to have a conditioned airspace? Because we know that a conditioned airspace has higher requirements for insulation systems and for air leakage. We're looking for a modern insulation system. And what does that mean? That means it's compliant with the 2012 IECC or ASHRAE 90.1 2013 or later editions. And again, we have flexibility on that. And the occupancy, less finishes, it makes it easier to test. But again, we're flexible. So the question is, why would you want to participate? Well, for one, the testing is provided at no charge. So the testing firm shows up, does the testing, and you see no charge. You can learn about air leakage testing before it's required. And it's going to be required soon, as I mentioned earlier in the presentation. It's coming. So I would like to know how well, what's involved. And I'd like to see how my crews currently perform. I mean, this is a great way to test how well your crews can install the insulation systems. And if anyone attended Tim Kessel's presentation about a week and a half ago, his whole presentation was on installing insulation systems and doing it right. And so this is a great way to test to see how well your crews are performing in the installation of insulation systems. And you can help contribute to best practices. And the other thing would be, is if you're looking for a way to distinguish your company from others, you can say that we're skilled in doing, we have buildings that have been tested according to the air leakage standard, air leakage testing standard, and our buildings pass. And I think that that's a big selling point. Because energy compliance, building owners, I would say, want to have an energy efficient building. And saying that you pass this test, I think would distinguish you from others in a very good way. So now you're sold, you go, Vince, I want to participate. So how do you participate? So you contact me and you go, well, how am I going to do that? Well, this is my email address. Or you can call me. I'm well versed in multi forms of communication technology. After you do that, I'll provide you with some standard forms at their page, and where you basically provide information on the building that you would like tested. And it includes the location. It includes the insulation system that's supposed to be installed. It asks about the number and size of the overhead doors, some basic information that we can take a look at. Now, we don't test every building you know, every time someone says, I'd like to get my building tested, we want to take a look at it. If it's a system that we've already tested, maybe already 2 or 3 times, we don't necessarily want to do that over again. We want to make sure we get the full range of insulation systems and different types of buildings, configurations, so we can actually have different data points, different information that we can apply into the best practice guides. So the MBMA air leakage task group takes a look at those, and if it gets approval, then we'll schedule the test that's convenient to you. And it's really scheduled on getting that building envelope complete. The windows in, the doors in, the insulation system in. So that pretty much covers the content of my presentation. I do want to take this opportunity to thank Sasha, Demian, and MBCEA for allowing me to make this presentation. I also want to thank the MBCEA members that have participated in the air leakage program. And, you know, we can't do this air leakage, we can't do this project without you. We want to be able to do this test while the building's under construction, and without your assistance, we just couldn't do it. So I want to, again, thank MBCEA and all the members, and we hope that we can be working with more of your members as we move forward. I do want to thank MBMA, and I also want to thank the members of the MBMA air leakage task group who've traveled and attended the testing and helped coordinate many of the projects. So I really appreciate your help. Couldn't do this. MBMA could not do that without our member support. I also want to thank NAIMA. They're co-funding this project, and we appreciate their support and their co-funding. So with that, if anyone has any questions, I would be happy to answer those.
We do have some questions, Vince. So the first one is, how long does the testing take and what does it typically cost?
So let's just say we're doing a standard test, and this would be the required by the building code. And that would not involve sealing the doors. I think you can appreciate sealing the doors takes a good amount of time, but it would take less than half a day to do the testing. That's pretty much our experience at the last building we did in Groveland, Florida. We pretty much got there, got things started by 8 o'clock, and we were pretty much done by noon, which actually worked out pretty well because, you know, if you visit Florida in the afternoon, thunderstorms come through, and that's what happened. So we were done by noon, even with the cleanup. Now you throw in the overhead door ceiling, and that kind of varies. But the testing firm has gotten pretty good at that, and we can get the whole thing done, pretty much done in a day. As far as costs go, one cost, let's exclude all travel costs, because if you have to travel across the country, that's going to be significantly different than if it's a building right around the corner. But what we are finding is for a basic, for example, the Cannon School, the testing cost less than, it was at most a couple of $1,000s, and that was it.
Okay, great. Next question. Are there specific insulation systems you are currently targeting?
Well, I'd have to go take a look at our list, but right now, well, let me just share with you some of the systems that we haven't tested right now. We have not tested anything with insulated metal panels on a metal building. And I think that that would be very interesting to test. I think we would like to test more of, say, the field cavity systems of all the buildings that we've done. And we've only tested, we've tested one of them. We would like to get some more information. I don't believe we've technically tested a long tab banded field cavity insulation system. So that would be one. And again, we want to get more information on the newer systems that need to meet the current energy codes. So those are some things just that I know that we're looking for. But if you have any questions, you have a building with an insulation system, send it to us and we'll take a look at it.
Okay, great. Next question. Do you recommend trying to do an air leakage test myself?
Well, the question is, you know, some people just like an excuse to buy new tools, right? And if you're looking for an excuse to buy, you know, some fans, you know, isn't there a company called the BA Fan Company? If you're looking for an excuse to buy some high-powered fans, you know, go ahead. But I would rely on testing professionals to do the testing, at least for your first one. Figure out, and again, I think that there's qualified firms all across the United States. We're working with one. They're based in North Carolina. And I would go with the professionals first. When we started this project, we actually considered buying our own equipment and doing the testing ourselves. But some of the task group members reached out and looked at some other testing firms and found high performance building solutions in North Carolina. And I am thankful that we selected them because they have taught us a lot about how to do an air leakage test. So I would go, at least for the first one, hire a company to do it. Then I think, then when you understand it, you see the equipment, then you can make a decision to do it yourself.
Okay, very good. Next question. It would seem the overhead doors are largely responsible for air leakage in some cases. Can they be exempted from the test, or must you meet the requirements including the doors?
Well, that's the beauty of the whole building air leakage test. It's the whole building. So you can't exclude it in the test. That's just the way it's written. And what's interesting, if you dig into some of the subsections of the air leakage testing requirements in the building code, you'll find that so you would think that if I have a door that's rated for air leakage, that would perform better. And I think that is true. However, if you let's just say you have an unrated door, it was never tested, and it's installed in your building and the building passes, that's fine. The door doesn't need to have an air leakage requirement, pass an air leakage test of itself. So again, it's the whole building. And that's the, there's a positive to that, because, and I think this is one of the reasons that you're going to see it more, this requirement more often or sooner than later, is that you're testing the installed condition. For everyone, for people experienced with the energy code, it's kind of the difference between an R factor for insulation, which basically is measures the thermal resistance of that component, versus a U factor, which takes into account the assembly. And what you want to know is, in the end, and that maybe not just you, but the building owner, how well does my building perform? And I want to know how it performs when everything, all the pieces are together. And so, again, the number is actually the whole building. And the reason, again, when we do the test, we know that the doors have a significant contribution. And so we seal it off because that helps us focus on things that our members can control. Our associate members in the insulation business understand the insulation systems. That's something they can control, not necessarily the doors. But again, we've gotten the door manufacturers involved so that moving forward, the doors should be able to perform better in the future.
Okay, thank you. Those are all the questions we have. Thank you, Vince, for sharing the results of the testing you've done on our MBCEA member buildings and how our members could benefit from continuing to participate. We look forward to hearing more about the progress of this project. Thank you.
Just to interrupt, Sasha, I'm hoping that a year from now, at the next joint meeting of MBMA and MBCEA, and that's going to be in Nashville?
Yes, in April.
In April. So I am hoping that next April, we're going to have at least 5 more buildings tested, not including the ones at C. Tucker Cope and Associates. So 5 more. So we would have the results of 11 buildings, and that we will have a draft of the best practice guide, and that we'll have the opportunity to present that at that conference in Nashville next April.
Fantastic. We are going to put that on the schedule. That is one less slot that I have to fill. Thank you.
You're welcome.
Fantastic. I look forward to it. It was exciting to see all of the member names, J.W. Wilson, Steelworks, C. Tucker Cope. They're all our members. We're excited. We appreciate everyone participating. If you read our newsletter, which you better be reading the newsletter that I put out monthly, we have an advertisement on the bottom for Vince's project. And so his contact information is always in our newsletter, and I'm glad that people have been responding, and I hope people continue to. So again, thank you, Vince. We really appreciate your participation.
Well, thank you, Sasha.
Thank you all again for attending. Please rate this session right there in the app. Before you log off, make sure you visit the exhibitor profiles, especially if you're on here for the first time. Also, some new exhibitors might have displayed some products since you last went through them. Many have exciting promotions going on throughout the virtual conference. You're also going to find the MBCEA Building of the Year presentation in the exhibitor profiles. We are featuring all the entries that we received and the winners. So it's a great presentation. Plan to be in attendance on Tuesday, June 16th, again at 1 p.m. Eastern Time, for our newly added interactive session by 3 of our member companies about how they're using technology in their business and how it might benefit you. Lastly, we want to thank our conference sponsors making this free virtual conference possible. See you all on Tuesday.